Who? Braden, what's the answer? You're right, it is 3. The slope, back from geometry, the slope is the number being multiplied by the x. So the slope of this is 3. What? It was this, but we didn't have our answer, so you can just write the same as yesterday, write 3 again after. Alright. Today, we're going to be talking about slope. And this is the last section in the book. Don't forget, after this, we're going to review tomorrow for your test on Friday. Oh, wait, today's Thursday, isn't it? Test Monday. I will be giving you a printout of the study guide we'll be going over tomorrow. You'll have a printout of it to look at over the weekend. You can come in that morning to ask questions. Okay. Now, the slope of lines is easy. It's just the number being multiplied by x. What if I gave you something else? What if I said, what if your function is x squared? What's the slope of that thing? Who can tell me? Good try. Let's look at x squared. Another good try. That's approximately x squared, right? And what is slope? Slope means how much it's rising and falling. What can you tell me? Let's say take this particular spot on the graph. What's that slope? Who can give me a generalization about it? Going downhill, right? Which makes it what? Negative. What about the slope right here? It looks pretty darn close to what? What about here? Unless it's a line, the slope is ever changing. At any point on your graph, your slope is going to be different. So, how can you tell me at any given point what the slope is? You can do that with what we're going to do today. You can do that with this formula, with only formula of the day. You need to write it down. We'll talk about it. This is the only formula of the day, and you only have 6 problems. Yeah, I think it's really long. What? This is 11.4. Oh, a long time to see it. Looks like Maddie, right? Never do that to me. Coach will always remember me. Yeah. Are you recording? Yes, I am. It's the instantaneous rate of change. Yes. This is instantaneous rate of change. It is. Did you get online? Yeah. We did it in the other class yesterday. This class turned to 3 days. So you already know this? You watched the video? Where are you going? Excellent. Yeah, turn it on. You can unmute it first. Hey, so you've already done this, but here's the video. We cannot 1 to 10. Same thing the hardest one, maybe easiest. What would you rate? Okay. There you go. No, but you're always asking me if it's easy. I heard from her.
Okay, but I didn't want to do the rational one. We said that we were going to do that.
No. Actually, I cut it down to 2 ways.
Yeah. Oh.
You didn't do it. Okay, so thank you. Okay. Who can tell me the slope formula? Kim. Slope intercept. How do you find slope? Hold on, Braden. What is he telling me right now? Listen. And Caleb too. Do you have a question? Calm down. You can still answer. How do you find slope? Y2 minus Y1. That's right. Let's write that down. Y2. You don't have to write that down. I'm just writing it down. Very good. Now in this class, one of the very first things we did at the beginning of the year was we said, you know what, instead of using y, we're going to start using function notation. So instead of y2, we're just going to call this f of x2. And instead of y1, we're just going to call this f of x1. Same exact thing. Just instead of writing y, we're just going to notice that you can get those y values simply by plugging x into the function. Okay, very good. No. No. I'm simply showing you where the formula up top is coming from. Okay, so let's take a function. Let's look at this function. Let's say, how many points do you need to find slope? 2. Right. So, here's what's going to be tricky about this formula. Instantaneous rate of change. That implies that at one instant a slope is something, but that's impossible. Brayden and Caleb, stop talking. That implies that you can have slope for 1 point, which is impossible. So what we're going to do is we're going to take 2 points and use that to estimate the point in between their approximate slope. So let's look at a quick example. Let's say here's a random function, and I want to know the slope between, we'll call this the x-axis. X is 2, and x is 6, right? I want to know the slope between the points x equals 2 and x equals 6. So you put 6 and 2 in here, and this would be f of 6 and f of 2, correct? I mean, we don't have a function to go with that, but assuming we had f of x equals x squared plus 2 or whatever, then that's where we get the y values, right? 6 minus 2 over f of 6 minus f of 2. Well, this is just going to be, this distance right here, isn't that just always going to be the difference between these two numbers? Mm-hmm. So we're just going to call that h. H, simply, in this formula, literally, h simply stands for the distance between the x values. Okay? That's all it stands for. Now, what's going to be a more accurate slope? If I was trying to find the slope of this, what would be the more accurate slope? This one? Or if I were to take the points closer? Which of those two slopes, 1 or 2, would be more accurate for that exact point? 2. The closer we are to our point, the more accurate our slope's going to be. So what this formula does is, it says, we're going to look at the distance between those 2 points, and we are going to round that distance down as close to 0 as we possibly can using a limit. So we're going to take 2 points so infinitely close to our point that it's going to be, even though we're using 2 of them, it's going to be pretty much the instant rate of change for that one exact point. So this is nothing more than the slope formula rounded down to a nub where we're pretty much right on top of each other so that our slope will be as accurate as possible. Now I'm going to show you how to use this formula. And it's really not so bad. Alright. I'm actually going to cut off these for right now. Let's jump straight into number 3. We're not starting with number 1 for a reason. Part A, well, we'll talk about this in a second. First thing I want to do is part B, which is basically find the slope-intercept equation, which is nothing more than the instantaneous rate of change equation. This formula, notice, it doesn't equal a number, it equals a new function. This formula is going to give you a new function, and that function is going to give you your slope at any given point. Let me show you what I mean. Alright, so we are looking for essentially the slope equation for number 3. We're looking for f prime of a, which is really f prime of x. But yeah, this is called a prime, by the way. Alright, so our original formula was f of h plus a minus f of a all over h. It could have been a plus h, it doesn't matter. Now, where most people get confused on this section is they think, what is this? What is f of h plus a and what is f of a? We're on number 3. What's my f function on number 3 that it gives us? X squared plus 4. First thing you need to do on all these problems is find f of a and f of a plus h, or h plus a, however you want to write it. F of a, you just plug a in for every x. Just like if you were to plug f of 3, you'd plug 3 in for every x, same thing. So if I plug a in for x, that simply becomes a squared plus 4. And then I'm going to do the same thing. I'm going to plug a plus h in for x. So this becomes a plus h squared plus 4. You simply plug a into your equation and a plus h into your equation. Before I go any further, are there questions about where I got these? The formula. Yeah. me go ahead and write this in the correct order so it doesn't confuse people. It's actually a plus h. Okay. Okay, now, before I can just start plugging things in, this right here, I can reduce this. Or not reduce it, I can expand this. What is a plus h squared? Yes, you have to FOIL it. That's a plus, darn it, don't do this today, board. That's a plus h times a plus h. When you FOIL this, you get 2a squared. I'm sorry, no you don't. You get a squared plus 2ah plus h squared, and then you still have your plus 4. So that is nothing more than f of a plus h expanded. All I did was go ahead and FOIL this out and write it here. Now, we've done that so that we can now plug f of a plus h into the equation and f of a into the equation. So we actually have things we can work with. Notice, I didn't bother writing the limit up here yet because it won't come in until the end. But don't forget the original formula did have the limit as h approaches 0. But we'll get to that in a minute. Okay. So I plug in f of a plus h. A squared plus 2ah plus h squared plus 4. That was f of a plus h. I just plugged it in to the equation. Minus f of a, which was a squared plus 4. And all over h. Now, what subtracts? What cancels on the top? A squared minus a squared. 4 minus 4. If you do this correctly, your entire right side equation should cancel. If you did it correctly, everything that you're subtracting over here should cancel with something on the left. So what's left? 2ah plus h squared. What factors out of the top? H. H. What reduces? So, this whole thing has melted down into this. Now I'm going to rewrite the limit up here. Remember I said I just didn't want to write it a bunch of times? There's still this limit. As h approaches 0 of 2a plus h. That's what the whole thing has reduced down to. Now the last few days, what have we done? Whenever we have an equation and a limit, what do? We just plug it in. So I'm going to plug 0 in for h, and what does that give me? 2a. So, remember, this whole thing was for f prime of a. F prime of a, which I'm about to plug in x for it, I don't know why they don't anyway, is 2a. In other words, f prime of x, I really don't know why they put it as a. It's really better as x. F prime of x equals 2x. That means, here's what we've just found. We have answered part B of the directions that said, find the equation for slope. From this equation, what we started with, x squared plus 4. If I were to ask you now, any point on that graph, if I said, hey, what's the slope of that function, the instant slope, at x equals -1, they give you the y value too, but you don't need it. Really all you need is x. What is the instant slope at x equals -1 for that equation? You plug it in right there. This prime is the slope equation. So, part B was simply find the equation. Check. Part B said find the slope at the given point. So now I need f prime of the point it gave me, -1. And what is that, -2? And that's the answer to part A. Here's part B. Here's part A. That equation will tell you the slope of this function at any point. What if I was curious about what is the slope at x equals 6? It's going to be 12. What's the slope at -8? It's going to be -16. You know, just the same as slopes in geometry. And that's what we're doing today. That's the only thing we're doing today. What? Part B is the actual formula. I think it's kind of got it backwards. And part A is... That is everything we're doing today. Now, there are going to be some of these. In fact, 2 of the 6 questions you have today are going to be like this, so don't overthink them. Oh, I'm sorry, I didn't mean to click that. Yes. Look at number 1. We are asked to find basically the equation for the slope. Braden, what's the slope on number 1? 2. Is it going to change ever? It's a line. I can show you. We can do all of this, but when we are done, what all this is going to melt down to. See how here it melted down to 2x down here? This one would just melt down to 2 because it's never going to change. The slope is going to be 2 all the time. That's what it's going to be. So for this one, I don't care if you just jump the gun and say the slope is going to be 2, both all the time and for any given point. There's another one on the next slide just like it. If it's just a line, you just pull out the slope, the way you always have known now. But all the rest of them, you can't do that. That's right. Maybe you have. That's right. As long as you remember what I told you about the linear one. So it's not changing, so there's no point in doing it. Yeah. Sure. Let's look at number 7. That one looks trickier because it has multiple x's in it. Sure. Who just asked you that? Okay, sorry. Now it's covering your mouth. Yes, the equation was f prime of a equals the limit as h approaches 0, right, from what you originally wrote. So what they're wanting you to do is plug this stuff in, reduce it as far as you can. And this was as far as we could reduce it. Once you've reduced your function, you know how the other day if we had like x squared minus 25 over x plus 5, you could always just reduce it, then plug it in? Same thing. They say reduce it, then when it's down as far as you can, plug in 0 for h. Because the whole point of this is to minimize h, make the distance between those 2 points as small as possible. So you just plug in 0 for h, and whatever you're left with is your equation. And once you get down to that, just change your a to x every time. I don't really even know why they call it f prime of a. I prefer. Yeah. Yeah. Yes. All right. Let's look at number 7. I'll take it elsewhere. Now, here's the order. No, that's a 2, 6. X is 2, y is 6. You don't need the y value. All they're saying is that the point 26 is on our function. If you plug the 2 into f, you would get 6. I don't know why they even added it, but nonetheless, you don't need the 6. All right, so the first thing we have to do is find f of a plus h and f of a. And then we're going to plug those straight in to this formula. Let me write f of a above because it's the easier one every time. F of a, don't waste your time thinking about that too much. That simply is plug a in for x to a squared minus a. That's all that is. F of a will never be difficult, just substitution. F of a plus h, you'll have to do a little math. So that's going to be 2a plus h squared minus a plus h. All I've done is plug a plus h in for every x in our formula, in our equation. Before I start foiling and subtracting and adding like terms, if there are questions about where I got f of a plus h that I've written up there, about where that came from. No? All right. FOIL. A plus h squared, a squared. I'm not going to ask you to do anything more than square all day, so it's always going to be that when you FOIL it. Minus a minus h. Don't forget to distribute your minus sign. That's why it's minus a minus h. So that'll become 2a squared plus 4ah plus 2h squared minus a minus h. And you can't go any further. I just multiply, yeah, that's all. And as soon as I give you all a chance to look that over and ask your questions, we'll start plugging stuff into the formula.
How did you get on the third one?
Right here?
Yeah, how did you get 2a?
When you FOIL a plus h, that's a good question. When you FOIL it, here's what you get. You get a squared, ah, another ah, therefore giving you 2 of them. So technically it's ah plus ah, but I just went ahead and combined them. All right. Good question. I've missed these questions. Not enough questions while you were gone. Yeah. I mean that as a compliment. Nobody would ask them. What? You know, I don't know. They should have. It seems confusing to plug. I don't know. So does that comment. Makes my head hurt. Okay. Here we go. Now we're going to start plugging it in. Don't quit. I'm joking. It just wasn't a productive statement. Okay. F of A plus H. I'm going to plug it in. Now I'm going to subtract F of A. All over H. Again, if you do it correctly, everything on the right should cancel. 2A squared minus 2A squared. Negative A minus a negative A, so it's negative A plus A. Also, if you do it correctly, everything you should be left with should have an H in it. 4AH plus 2H squared minus H over H. What factors out of the top? If you do it correctly, yes. Go on, ask it. Okay. Then those should cancel. You can't. Here's the thing. If people just take the H out, here are the most common mistakes I see there. People cancel this and they think it's just gone. And when they cancel this, they think it's just gone, but there's a 1 there. You can just take the H out, sure. But just remember your algebraic principles. Okay, so now that we've reduced it as far as we can, the limit as H approaches 0 of 4A plus 2H minus 1. That's right. Plug in 0 for H, and you're left with. Alan, once I plug in X for this, what's that going to make F prime of X? Just A. Yeah, it's just the same thing with an X in there. Yeah, it will. Yeah, because the original function of F is F of X. That's right. F of X is your function. F prime of X is your derivative. I mean, is your well, it is both derivatives, but we'll talk more about that in calculus. Is your slope function? Yeah. This is part B. Part A is just punch in the value. What was the value of there? 2. Yeah. So part A is F prime of 2. What is that? 7. So at 2, the slope of your original function is 7. Rising 7 over 1. They show you a bunch of shortcuts and stuff when you get there. You plug 2 in. 4 times 2. It was in the original problem way up there. Yeah, just plug the X in and it'll get your instant slope at that point. Actually, yes. Part B, part A. Yeah. I don't really care if you label them B and A, as long as I see both. It makes sense that the other one would be part A, but whatever. Okay. Not yet. Any questions on this problem? The only difference, and it's not harder at all.
I said Buck.
Oh. Very clever. You said Buck. Don't do that. The only difference between these, and there really is none, the only difference is it gave you 2 points to plug in instead of 1. Yes, so you'll have 2 different answers. So like this one, number 15, you should save yourself some problems and just say the slope is going to be what? That's right, so spare yourself. F prime of X, the slope function, is just going to be -3. So no matter what you plug in for it, it's just going to be -3. Let me show you what that answer would look like. 15, without even having to do anything, you could say F prime of X is -3. There's not even an X there because it's never going to change. F prime of 1 equals -3. F prime of 4 equals -3. That's all you have to do when you come across one like that. 17, you'll do just like we just did. You'll have to do that equation, but when you're done, you'll actually just plug in two different values, get two different slopes. Only different. I'm glad you think so. No. I mean, you can. You can do the equation, but you would get -3, so just spare yourself. A lot of people, see, the other class didn't earn a free day yesterday, so they worked this, and they said, I think I did something wrong, there's no X. I said, no, it's a line. It's not going to change. Okay, let me change these numbers. This is even only. Even only.